Hey guys, in this video we're going to be taking a look at some more area between curves. And specifically in this video we're going to be looking at area between curves using a calculator. So we haven't actually done a lot with our calculator in this class. Most of it has been really operations you can do without a calculator. You might have used it, but we haven't really done any sort of major function operations or any really that much graphing either. And part of that is intentional in that on the AP test, really more than half of it is without a calculator, and then less than half of it is actually with a calculator. However, there are some things we need to use a calculator for, and in this set of problems, we are going to be finding the area between curves using a calculator. So I'm going to demonstrate how you do that. It's going to be a very similar setup as we had in the previous video, in the previous set of problems, where we were doing the top function minus the bottom function. It's just in this one, some of the computations are going to be a little bit too challenging to do by hand. You could do them, but it just is easier with a calculator, and the AP test would expect you to do them with a calculator. So that's what we're going to do. So let's go and look at our first example. We're supposed to find the region bounded by these two curves. You can see we've got a parabola that opens down right here. So that's our f of x, right, because it's a negative 3x squared. And then we've got our other line, g of x, right here. And we're going to try to find the region bound by those two. All right, so if you remember, when we're trying to find the area between two curves, we do this integral, which we do the integral of the top minus the bottom, essentially, right? And then we've got an a and a b, which are the limits, and those are the intersection points. So this would be our a, and then this would be our b. So that's our basic setup. So let's go ahead and write this out, and then we'll go over how we do this on the calculator. So we write this out. It's going to be the integral from, now this point is actually not exactly clear, right? It's somewhere between negative 1.5 and negative 2. So we can't actually find that at this moment just by eyeballing it. So I'm going to not do that right now. This one, it looks like it's at positive 1, but not exactly sure. So let's just hold off on the limits for a sec. Let's go ahead and do the top function minus the bottom. And in this particular problem, f of x looks like the top function, right? Don't always assume the first is the top function, even though the formula is that f of x minus g of x. Don't always assume f of x is going to be the first function there. All right, so we are going to be doing negative 3x squared minus 1 minus the function 2x minus 6 dx. That's what our integral looks like, right? So what we're actually going to do is type that into our calculator. And I prefer not to actually do any sort of combining or anything when you do this in the calculator, because then it just eliminates any chance of error. Your calculator, as long as you type it exactly like this, you don't have to worry about if maybe you distributed the negative sign wrong or something like that. So we're going to type this in to our calculators in the Y1 section. So power up your calculators and do this with me. Go ahead and clear it out. And obviously, we've done this a few times. I'll try to use this here. Just go to your Y1 screen and go ahead and type that in. Make sure when you do type the second part of that function that you are putting in parentheses, so minus 1, and then minus parentheses 2x minus 6, close parentheses. So that's just all going to go into your y1. All right, and go ahead and graph that. Now you're not going to see a graph of this, right? You're actually going to see a different graph. It looks like that, which is downward facing parabola. That's good, okay? You shouldn't actually see that because we've created a new function, right? A new integral where we combine the two of them. If you did actually want to see this one, you can do that. And you can actually go ahead and clear that y1 for the moment. And let's go ahead and type these in as two separate functions. So negative 3x squared minus 1, and then y2, 2x minus 6. You don't have to put the minus in there because we're writing them as two separate functions. I'm basically just going to recreate the graph that we see up there, right? So go ahead and graph it. And you'll get a picture of exactly what we see there. Boom. All right. So what we're trying to find is the area between those two curves. Now, one thing that we said we still needed was the limits, right? We need to know where these two intersection points is. And if you remember from last year, we can find those pretty easily, right? We can find those intersection points on here. So to do that, we do the second calc and down to intersect, right? Second calc intersect. And then we have asked for a first curve with that question. So what you're going to do is you're going to move your cursor down close to where the intersection is. Mine's going to be down here somewhere. All right, sorry, this is hard to, but down there. And enter, and then it's going to ask you for second curve, enter again, and then guess, do enter again. All right, and then intersection, we're looking for x values. So we've got an x equals negative 1.66 tons of sixes. I'm going to go ahead and write them all out. You could probably not write them all, but we just need to be really careful with decimals on this because we got to round to the nearest thousand. So I'm going to just write all those out. And then we need to get the other intersection point. So second calc intersect again. And just move it over closer to where the second intersection is. Enter, enter, enter. And we get x equals 1. All right, so it was 1, but we don't want to make that assumption. So we've got negative 1.66 and positive 1. All right, so that's good. This is one way that we can find those intersection points is to just plot them as two separate functions again and find those two intersection points. So that's one way you can find the limits. I'm going to go ahead and go back to my y1 now and type this all in as my integral up here. I'm going to type that whole thing in there. Not the integral part, of course, but the function. So I'm going to go back to my y1. I've still got the first one there, and I'm just going to go up. And then now just go ahead and subtract the second one, minus, and then 2x minus 6, so that I've got the whole integral in there like that. And I'm going to go ahead and graph it again. All right, and again, this is our new function. So what we're going to be doing is we've sort of created a new function, and now we're trying to find the area under the curve of this new function. And there is a way that your calculator can do this for you. So all these definite integrals we've been doing by hand, it turns out your calculator can actually do those for you if you've ever wondered that, or maybe you've already tried that on your own and figure that out. But it's pretty simple. You just type the function into y1, and then all you're going to do is you're going to do second calc, okay, second calc, and you probably have already seen it there, maybe you just even recently. Right below intersect, you'll see down there, you actually got a dy dx, so that's for derivatives. We don't use that one so much. Mostly we use number 7 there, which is the integral one. So I'm going to go down to that one, number 7. We can just hit 7. And it's going to ask you for a lower limit. Okay, so you're just going to type in the lower limit we just got. And again, I'm going to be extra careful and just type in a bunch of those decimal places. So negative 1.66666667. All right, so that's what I'm going to type in for my lower limit. And my upper limit is just going to be 1. Let's type that in, enter. And then, boom, it actually shades all the area under the curve. So that's what it's telling you the area that you're finding is all the area under that curve right there. And we've got 9.481, so on and so forth. All right, and it says we want to round this to the nearest thousandth. So we've got 9.4 as tenths, hundredths, thousandths. So 481, and it's a 4 next to it, so we're going to keep it as a 1. So that is our area between those two curves. Now again, on your calculator, it looks like you're just finding the area under one curve, and that's because you've written this new integral here, right? You've written that new integral that's created this. So it's actually just essentially one curve, and you're finding the area under that one curve. You've combined those. So kind of cool how it works, right? Now, another thing that you can do to find these limits, if you don't want to type them in as separate functions and then find the intersection points, you'll notice that these limits are actually the zeros of this new function. So what you could have done is you could have done this new function, just type it in once, and you guys might want to choose to just do this, is just type that in, your new function, and then you just do second calc 0, and then remember how you do the left bounds and the right bounds. So you just move it somewhere over here where the cursor is, right? Enter on the left bound, and then right bound, you move it up over there somewhere. And then as you guess, enter again, yes. And you'll get that same negative 1.6667. So you can do it either way. If you want to find the zeros that way, that works as well. And it's probably easier because then you don't have to retype. You just, again, create your new function, and then you find the zeros, and then you do the integral. So this is not terribly difficult after you get the hang of it. the setup is the same, and then you actually have a lot less work to do, a lot less room for error because the calculator does the work for you. So let's go ahead and type that in, and then we'll move on to another example. All right. So let's go ahead and look at this one. So again, once you get the hang of this, it will go pretty fast for you, I think. So we're supposed to find the area under this curve again. Our two functions are, well, the first one is a function. You want to identify which is the top one. So this is obviously our f of x, the u, the parabola there that opens down, so that's our f of x. And then the line here is obviously our g of x, right? So if we're going to find the area between those, we did the top minus the bottom. So we're going to the integral from the top function is negative 4x squared minus 2x minus parenthesis. The bottom function is just a constant in this case, so negative 6 dx. Practice writing these out too, because on the AP test, if you have a free response question where you have to answer something like this, they're going to want you to show your work and show your evidence. And I'm not quite sure exactly how that will work on the digital version, but there is a digital practice that we're going to do. And so you need to document your work in some way if you want to get credit for all this. So I'm going to go ahead and do that. That is our integral. All right, now I'm just going to type this whole thing into y1. So just clear out your y1 and go ahead and type that in, negative 4x squared. And again, I would recommend just doing this with me while you're there. And you could obviously write plus 6 if you want to. That's probably an easier one to just go ahead and write the plus 6 doing that distribution. But go ahead and graph that. Again, you're not expecting to see this graph that you see on the screen. You're expecting a new graph, which is the combination of these two. So it should look something like this. All right, and then the next thing we need to do is find our limits. So instead of like doing the two separate functions and the intersect on this one, that certainly would work. But I'm just going to go ahead and find the zeros of this one. So I'm just going to go to second calc 0, my left bound just below, if you remember, left bound just below the 0, right bound just above the 0, enter, 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 and then you'll get it there. It's at negative 1.5, my left bound, and then my right bound, second calc 0, same deal, except for this one, you want your left bound to be above the axis, and then right bound below the axis, and we're at 1. So negative 1.5 to 1. So you could actually do this one fairly straightforwardly with do it by hand. But now you know how to do it on the calculator, and you're allowed to do that. So now we're going to go ahead and do second calc. We're going to go down to this integral, right? And type in lower limit as negative 1.5 and upper limit as 1. And you should see it shaded in that whole area. And we got our answer there of 10.417. All right. So in all of these, you should end up shading that whole area. If you don't, if you only shade like part of it or something, at least on this section, that means you didn't do your limit correctly or you didn't type something incorrectly. But all the area above the axis there should be shaded. Okay. All right, so that is how you do those. Anytime that you're allowed to use the calculator on the AP test, you should do so for like an integral like this. One, because it's less chance for error, because if you do it by hand, there's always a chance you can mess up. And two, because the AP test is timed. You have, might seem like a long time, like almost 4 hours, but it is timed, and these calculations take time, whereas your calculator is faster, so take advantage of it when you can. All right, maybe let's see one more, let's do a similar one. Let's do a slightly different one. Okay, here we've got two functions. All right, I'm just going to go through this real quick, and then we've got one more section here. All right, so again, it's going to be integral of the top minus the bottom. So we just identify the top function. The top function in this case is this lines, the linear equation here, negative 2x plus 6, minus the bottom function. The bottom function here is the parabola there, 2x squared dx. All right, so next thing I need to know is my intersection points for my limits there and there. Those are obviously things we can't tell exactly on this one. So you could now either plug in the two separate functions and do the intersect, or plug it in as one function, which I'm going to do to clear out your old one, and type that in, negative 2x plus 6 minus 2x squared. And I should put that in parentheses, even though just a good habit to do, minus parentheses 2x squared. And your graph should look like this, right? Just a parabola. And then we need to find the zeros, because that's going to be the intersection points for our limits there. So first one, left bound, move it below, enter right, move it above, enter, enter. And I get negative 2.302776. All right. I'm going to write out all those because Delta Math is kind of picky about decimals. Then I get a second calc again, 0. The left bound is going to be just above it, and right bound just below. And I get 1.30, a bunch of other stuff, 27756. All right, so now I'm ready to do my integral. So second calc down to number 7, my integral lower limit as negative 2.302776. Upper is 1.30275756. And again, it shaded the whole area there. And I got my area under the curve there, which is 15.624. So it's going to just be 15.624 meters thousandth. All right. So that is how you do area between two curves with a calculator. That is the basic example. Occasionally you will see some harder ones, so I am going to throw in a couple harder ones here, just so you guys are prepared for whatever scenario you encounter. All right, so this one's not bad. This one's actually might even be easier in this particular one. We're going to find this area, and notice this area isn't just a single shaded area bound by two curves because it's kind of cut off here. If we were to actually find the area between these two curves, this one's going to continue this way, this one's going to continue this way, and our shaded area would be actually all of this region, right? However, this is not area between the two curves by itself. It's also bound by this other line, x equals 0, which it says here. Okay, because it's the area between those two functions, f of x, g of x, and the line x equals 0. So it's kind of bounded on three sides. Now this one, like I said, is actually a little bit easier because, well, the only thing that's different is our limit, right? If we were to do all this area, it'd be the same setup, except our limit's going to be this intersection point here and this one here. But all this is doing is saying, oh, I'm going to change the lower limit. I'm going to change the lower limit to x equals 0. I only want to start there. So when we set up this integral, it's going to work the same way. Our top function, negative x squared plus 6, minus our bottom function of 1.5x plus 1. And instead of integrating from the two places where they intersect, I want you to start at x equals 0. Because remember, those limits are x values. And then go up to whatever then the other intersection point is. So I'll just go ahead and type in my function, negative x squared plus 6 minus parenthesis 1.5x plus 1. All right. And graph it. And you'll see this region. This one won't exactly match because this is what we're going to do here. We already found the left 0 kind of, right? Because we don't want this, we don't want this one over here. We don't want that 0 because we want to start at x equals 0. So we want to start there. So we're going to ignore this 0, our lower bound, and we're just going to stick with that one, x equals 0. And then so we do need to find this other one here. All right. So, and just realize things might look a little bit backwards on this to you. So sorry if that is the case. All right. We need to find the second 0. So I'm going to do second calc 0 and then find the right one. And when I do that, left bound, right bound, I get my right 0 or my upper limit as 1.60849953. So then my integral is just going to look like that. I'm going to go ahead and second calc number 7, my integral, and my lower limit is going to be 0, and my upper limit will be 1.6084. That's a 953. And you'll see it's just this part that's shaded now. And that should be good because we're, again, sort of cutting off that area. So just a smaller section there. All right, so 4.715 then. All right, and then I wanted to show you, let's see. Okay, here we go. This is where it gets challenging. So this one, we've actually kind of got 2 areas, right? And you'll notice that the function kind of switches which one is on top. Anytime you see something like this, just think 2 separate problems, essentially. You got this problem. This is our function here. That's got to be our negative x squared plus 9, our f of x, right? And then our g of x is this other one. It's a linear equation, 0.5 x plus 5. It's our g of x, right? Okay, so the reason why this you want to look at as 2 separate problems is because the top function switches, right? It starts with f of x being the top, but then it switches here somewhere in the middle to now this one being the top function. All right, so we're going to have 2 separate integrals. We're just going to add them together, though. We're going to have our integral from something to something. Now, the first lower limit is easy because it tells you cut off there. Y-axis, so that means x equals 0, right? So the first one is cut off at x equals 0. I'm going to leave the top limit open for right now because that's going to be the intersection there, right? So I'm going to leave that open. And this one's going to be f of x minus g of x, so negative x squared plus 9 minus parentheses 0.5x plus 5 dx. All right, so that's my first area. And then I'm going to add my second area. So plus, and this just switches. So now I'm going to start wherever the intersection point is. That's going to be my lower limit. I don't know that. And I'm going to end at the line x equals 3. Right? So that's going to be my upper limit, 3. And again, I'm not sure of that bottom limit yet. And now my top function is the line, the linear equation, 0.5x plus 5 minus my g of x, negative x squared plus 9. Just going to cut off there. All right, so I'm just going to do it as really 2 separate problems and then add the answers together. The rounding could be a little bit tricky on this. We'll see how that goes because we're going to be adding 2 different areas. All right, so if the rounding doesn't quite work out for you on this, but you get really close answers, then just let me know that you tried several and the rounding didn't quite work for you if you're getting really close answers. All right, so let's go ahead and do the first one. We are going to need to know this limit though, right? So to find that limit, I'm just going to go ahead and plug in the 2 functions. I think probably the least confusing thing to do would be to go ahead and plug in the 2 functions, negative x squared plus 9 into y1, and then into y2, 0.5x plus 5. Go ahead and plug those in. And I'm going to go ahead and do the intersect function on this one so I get actually the picture of what we got there. And you can see on this, we're just kind of just finding the area of 2 really just random regions, that one and then down here as well. So I'm going to go ahead and find the intersection. I want obviously the one that's the picture of what we're looking at, second calc intersect, and move it over closer, and we get x equals 1. I don't know why we're at 0 up there. X equals 1.7655644 and 1.7655644. All right, so those are going to be my limits. Not sure when I wrote those zeros there, but oh shoot, that was not supposed to clear that screen. All right, sorry about that. Let me rewrite this here. My first one is going to be from 0 to 1.7655644, and that is my negative x squared plus 9 minus 0.5x plus 5 dx, plus the integral from 1.7655644 up to 3 of now switching it. 0.5x plus 5 minus negative x squared plus 9 dx. So that is what you'd want to write to show this on the AP test. This is your work here to show how you do it. Then it's going to be just typing those in. It's going to be a bit tedious here, but would be better doing it with a calculator definitely than trying to do this all by hand. You could certainly do it all by hand, but this will hopefully be a little bit faster. All right, so negative x squared plus 9 minus parentheses. Again, make sure you're using parentheses whenever you subtract a whole function, and then you don't have to worry about distributing the negative sign. We are doing these in two separate problems, though, right? Two separate calculator operations. So I'm typing the first one in, graphing it, will look like this. And then now I'm going from 0 to 1.76, all that jazz. So lower limit 0, upper limit is 1.7655644. And I get 4.44844037. Now rinse and repeat for the other one. 0.5x plus 5 minus whole thing there, negative x squared plus 9, close parenthesis, graph it. Now I should have something like this. And this one we're going from integral from 1.7655644 up to 3. It's my upper limit. And area should look like that. And there we get 3.6984037. So I'm going to add those together. I'm just going to go ahead and from this screen, I think it'll work if I just hit plus. Yeah, it'll just take your answer for the plus, so you don't have to at least retype one of them. And then 4.4484037. And my grand total then is 8.1468, so nearest thousandth, 8.147. That should be the answer. Hopefully, Delta Math isn't taking rounded differently. All right, worked out. Okay, so you should be able to get those exact answers. You can see they've got the same setup there, adding the two integrals together, adding the two areas. So don't round until the very end, I guess is the moral of the story, right? There we go. Okay, and that might seem like it took a long time. Again, the more you do this, it's not difficult. It just gotta be a little bit careful where you're typing in. All right, let's just set up one more here, show you. So this one, we've got our top function to begin with here is that f of x, because that's a negative 2x squared. And then the bottom function, which switches, is now g of x. So we're going to have our integral from 0 as our first x boundary, right? 0 to, we don't know the intersection point. And f of x, so that's negative 2x squared plus 8 minus g of x, 2.5x plus 3 dx, plus integral from we don't know up to the line x equals 2. And now it's switching. Our g of x is on top, 2.5x plus 3 minus negative 2x squared plus 8 dx. You then need to find where they intersect. So again, I just typically like to plug these two in, find their intersection point, 2.5x plus 3. Double check that. Yep, intersection point gives us our limit. Second calc. And we're looking for where they intersect on the right, not the left one. So there's a further one. And that gives us 1.0. So I would type all these in, 1.0751838. And then this one starts there. All right, and then I'm not going to finish the rest. I think you guys know the story by now. You're going to type this one in, get an area, plus type this one in, get an area, add them together. and then round to the nearest thousandth. So that is it. Hopefully that is clear for you. If you are struggling with either how to do the calculator computations or just concept in general, do feel free to let me know. Yeah.